Good morning, class. We are looking at exam 4, review which covers from 4.4 to 5.4. Optimization problems, antiderivatives, fundamental theorem of calculus, the substitution. So these are some basic integration formulas from the power rule to logs, exponentials, sinusoidal functions, trigonometric functions, to FTC. FTC stands for fundamental theorem of calculus. So d dx of a, the integral of a to x, f of t dt is f of x. That means if you take the integral and differentiate that, you get the function back. And the integral of a to b f of x dx, which is called a definite integral, is a number capital F of b minus capital F of a. And the substitution rule says the integral of f of g of x, g prime of x dx, where g of x is u and g prime of x dx is du, is the integral of f of u du. And now the optimization problem, I'm going to look at a couple of examples and the concept, and then specifically we'll do some problems. Find two numbers whose sum is 54 and whose product is a maximum. First, you have to define the variables. Let the numbers be x and y. The objective is to maximize the product p equals x times y, and the constraint is that the sum x plus y must be 54. And you take it from there. If 5400 pi inch squared of metal is used to construct a cylindrical storage drum, what is its maximum possible volume? So first, you have to know the shape. You should know the volume is pi r squared h. And the amount of material you use is the concept of gift wrapping. The surface area, the area of the base is pi r squared. You have two of them, the bottom and the top. The surrounding, if you cut this open, becomes a rectangular shape with the height h would be one side and the other side would be the circumference of the base 2 pi r. So subject to s equals 2 pi r squared plus 2 pi r h equals the number given, which is 5400 pi. And you take it from there. And you apply the first or second derivative test for absolute extrema in the following manner. A local extremum is an absolute one if it's the one and only one extremum in an open interval. So a farmer has 2,400 feet of fencing and wants to fence up a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? First and foremost, you must draw the setting unless it's given to you. Then you have to define your variables. So the width is x, the length is y. So what you want to maximize the area, which is x times y. That is your objective. The constraint is 2,400 feet of fencing. The perimeter of a rectangle is 2 times the width, 2 times the length. So we have 2 times x, but one side, we have only one y because one side does not need any fencing, okay, because it's along the river. So 2x plus y is 2,400. As you notice, a has two variables, x and y. So we're going to solve for y, 2,400 minus 2x. You put it in there, and now a becomes a of x. X times 2,400 minus 2x. You have to figure out the domain. The domain is from 0 to 1,200, and the reason is x represents dimension, so must be positive. If you set 2,400 minus 2x equal to 0, it gives you x equals 1,200. And if you pick a number larger than 1,200, this becomes negative. We can't have it. So distribute and get it ready for calculus. So we start with differentiation because we want to find critical points, and a prime of x is 2,400 minus 4x. When we set this equal to 0, x becomes 600. So we have an open interval with one critical point. Local becomes absolute. You can go with the first or the second derivative test. Clearly, second is easier because a double prime is just a number, in this case, -4. The second derivative test says you have to plug in the value of the critical point because it's independent of x. It doesn't matter. A double prime is always -4, and what we care for is the sign. It's always negative. That means it's concave down. That means the maximum occurs because concave down looks like that. So the maximum occurs when x is 600. Put it in the objective function. Y becomes 1200 feet. So 600 by 1200 gives us the maximum area of 720,000 square feet. From a thin piece of cardboard, 10 by 10 centimeters, square corners are cut out that so that the sides can be folded up to make a box. What dimensions will yield a box of maximum volume? What is the maximum volume? So we have a 10 by 10, and we're going to cut X amount from each side, which means now this is X, and what remains here as the width as well as the length is 10 minus 2X. You fold it up looking like that, and you have X here, you have 10 minus 2X here, you have 10 minus 2X here, and the objective is to maximize the volume for a rectangular solid is length times the width times the height. Subject to what we just did, the constraint says the height is X, the width as well as the length, both of them are 10 minus 2X. So now we can make V a function of X by replacing the length and width with 10 minus 2X, and H with X, we get X times 10 minus 2X quantity squared. To continue, we're going to raise this to the power of 2, so we square this, we get 100. The product of these 2 times 2 is minus 4dx, and this one squared is 4x squared. And x must be between 0 and 5. Why is that? First of all, x must be positive, otherwise you're not cutting any corners. You're not creating any box. Secondly, just think about this. If you cut the 10 in half, you get 5 and there's no box, or 10 minus 2x equals 0, x equals 5. So if you go with a number equal to 5, the volume becomes 0. If you go with a number larger than 5, then you can't have this because this side, this is one side, becomes negative. And so you're going to square this. You're going to distribute the x, 100x minus 4dx squared plus 4x cubed. We put the 4x cubed first and we put it in descending order. Now we are ready for calculus. Everything we've done is algebra, geometry, you name it. V prime of x equals 12x squared minus 80x plus 100. Because we are looking for critical points, we want to set this equal to 0. We're going to factor what we can. We notice between 12 minus 80 and 100, 4 is in common. So 4 times 3x squared minus 20x plus 25. Three is a prime number. So you have 3x and x. 25 is the product of 1 and 25 or 5 and 5. And because this is positive, both of them have the same sign. Working it out, we end up with 4 times 3x minus 5 times x minus 5 equal to 0. And either this one is 0, which means x is 5/3, or this one is 0, which means x is 5. We have an open interval of 0 to 5, so we get rid of the 5 because it can't be equal to 5. We have an open interval with one critical point, which means local becomes absolute, and we don't know which one we have. So we go with the second derivative test, becomes 24x minus 80. You have to plug in your critical point and evaluate to see if it's positive or negative. So v double prime of 5/3. This cancels out this one. 8 times 5 is 40. Minus 80 is minus 40. We are interested in the sign. The fact that it's negative, it makes it concave down and therefore maximum, because concave down looks like that. So maximum occurs when x is 5/3. So what is the width? What is the length? 10 minus 2 times x, or 5/3. 2 times 5/3 is 10/3. So we make 20 into 30/3, and therefore we have 20/3. The dimensions would be 5/3 by 20/3 by 20/3. The volume would be the product, the numerator. 20 times 2400 times 5 is 2000. 3 cubed is 27. So 2000 over 27 is an exact answer, or 74 and 2 over 27 cubic centimeters. Find all functions g such that g prime is 4 sine x plus 2x to the power of 5 minus square root of x over x. In general, to find the integral or the antiderivative, the methodology is, sometimes you will need to simplify first factor, cancel, remove, radical notation, etc. Sometimes you will need to integrate using substitution. So the first thing is to make up two fractions here. This is 2 x to the power of 4. This one is x to the power of 1/2. 1/2 minus 1 makes it negative 1/2. So we have 4 sine x plus 2x to the power of 4 minus x to the power of negative 1/2. So to find g of x, we integrate the right side times dx. Sine, the integral is negative, so minus 4 cosine x plus 2 over 5 x to the power of 5 minus 1 over negative 1/2 plus 1 x to the power of negative 1/2 plus 1. There is nothing else. We add a constant at the end. Negative 1/2 and 1 is positive 1/2. And this is 2. Minus g of x is minus 4 cosine x plus 2 over 5 x to the power of 5 minus 2 square root of x plus c. We are going to integrate term by term. The first one, each and every one of them use the power rule. So the first one, 2x to the power of 4 is 2 over 5x to the power of 5. This one we add 1 becomes 4, 3/4 x to the power of 4. This one we add 1 becomes 3 minus 7/3 x cubed. This one, when we don't see an exponent, the exponent is 1. So 1/2 x squared. And this one is minus 5x. There is nothing else. We add a constant. To do this, first we are going to use a minus b squared equals a squared minus 2ab plus b squared 2 squared. So this becomes x squared minus 10x plus 25. So this is 1/3 x cubed. This has exponent 1, so minus 10 over 1 plus 1, or minus 10 over 2, minus 5 x squared plus 25x, and a constant. Dealing with exponentials, when you differentiate, you multiply by k. When you integrate, you divide by k. So the answer is always itself. In the case of integration, we're going to divide by 4. So 1/4 e to the power 4x and a constant. What about this one? The answer is itself. Divide by -3. So -1/3 e to the power minus 3x and a constant. This one, just write x to the power of 2 as x over 2 as a half of x. So it becomes clear the coefficient of x is 1/2, and therefore it's 1 over 1/2 e to the power of x over 2 and a constant. Therefore, 2 e to the power of x over 2 plus a constant. Now, if you see what you're dealing with, more power to you, but if you don't, I highly recommend you rewrite it as 2 times 1 over x, because you know the integral of 1 over x dx or x to the power minus 1 dx is natural log. So 2 times ln of absolute value of x plus a constant. Same thing here. Let's rewrite it as 1/2 times 1 over x. So again, this piece is a natural log. 1/2 remains. So 1/2 ln of absolute value of x plus a constant. The definite integral of a to b f of x dx is capital F of b minus f of a. So the definite integral of 0 to 1 x to the power of 7 dx, you integrate this, you get 1 over 8 x to the power of 8. You don't need a constant because you're evaluating. You put the 1, you put the 0, and you get 1 minus 0 times 1 over 8. We have 1 over 8. The tip is, and this is important, even if we use another antiderivative, that means we add a constant here, capital F of x plus c. In the evaluation theorem, the result will be the same because capital F of b plus c minus capital F of a plus c is still capital F of b minus capital F of a. All right. Notice x to the power minus 1 means 1 over x, and therefore the answer is a natural log. Again, we don't have a constant because it's a definite integral. The limits, the bottom and the top, are both positive, so you can lose the absolute value. You get ln2 minus ln1. We should know ln1 is 0. And therefore, the answer is ln2 precisely. Now, what happens here, you get the same situation with a different set of limits. Because the limits are negative, we have to keep the absolute value when we evaluate them, because natural log of negative numbers or 0 make no sense whatsoever. They are undefined. The domain for basic natural log is from 0 to infinity. 0 is not included. So this one is ln1 minus ln2. And as you know, ln1 is 0, so minus ln2. And bear in mind, this one as well as this one, we are showing the exact answer, class, okay? The integral of 0 to pi sine, you know the derivative is cosine. The integral is negative cosine, and we're going to evaluate it from 0 to pi. So we're going to take the negative sign out and say we say cosine of pi minus cosine of 0. Cosine of pi minus 1 minus cosine of 0 is 1. So we are looking at negative 2 inside the brackets times negative positive 2. How do we integrate the integral of x squared minus 7x plus 2 over x squared? We make up 1 2, and 3 fractions. The first one is 1, the second one minus 7 over x, and the last one 2 over x squared. Furthermore, minus 7 over x is minus 7 times 1 over x, and 2 over x squared is 2x to the power minus 2. Therefore, we are ready to integrate term by term. 1 gives you x, minus 7 times 1 over x gives you ln x. And this one is 2 over negative 2 plus 1 x to the power of negative 2 plus 1, which is negative 2x to the power of negative 1, or minus 2 over x plus a constant. One plus cosine t minus secant squared t dt, because the independent variable is t, 1 gives you t. Cosine, the derivative is negative, but the integral is positive sine t, minus, remember the derivative of tan is secant squared, therefore the integral of secant squared is tan x, and therefore the derivative, the integral of secant squared t minus secant squared t gives you minus tan t and a constant. Cube root of x minus sine x dx. We're going to change this so that the power rule can be used. X to the power of 1/3, we write 1 over 1/3 plus 1, x to the power of 1/3 plus 1. You can say the integral of minus sine is positive cosine, or the integral of sine is negative cosine. So minus and minus cosine x and a constant. It makes no difference. Ultimately, this becomes plus. What about this one? This is 4/3. So we are dealing with 3/4, the reciprocal. X to the power of 4/3. We can write this back into the radical format. So we get 3/4 cube root of x to the power of 4 plus cosine x plus a constant. Initial value problem. What is an initial value problem? Reminding everybody. Any equation containing a derivative is called a differential equation, or DE. A function which satisfies the equation is called a solution to the differential equation. An initial value problem is a differential equation along with a specified value of the unknown function called the initial condition. So, first and foremost, when you come across an initial value problem, ignore that initial value and get on with the integration by rewriting this as dv equals to the right side times dt, and integrate both sides. So the integral of the left side is v of t, the integral of the right side. Both of them involve e, so the answer is always itself. In this case, v divided by negative becomes minus. In this case, it's itself and a constant. V of t is minus e to the power of negative t plus e to the power of t plus a constant. This is a general solution, everybody. Because we have a constant, we have infinitely many solutions. We have a family of functions. This pair 0, 3 will help us find the missing constant. So plug in. Replace the t with 0. E to the power of 0 is 1, so is this one minus 1 and positive 1. They cancel each other, and c becomes 3. Replace it. And a general solution in this case become a particular solution. Okay. This is a family of functions, infinitely many solutions. This is one of those. Now I want to integrate 2x times x squared plus 5 to the power of 30 dx, and we are going to use the substitution. So here's the tip. Look for a function u equals g of x anywhere in the integrand, and its derivative du or g prime of x multiplied by dx. So you have a polynomial x squared plus 5, you have a polynomial 2x, and the more complicated one, in this case, x squared plus 5, is the choice of you. So what is its derivative? 2x. So du dx is 2x, which makes du 2x dx. To be clear what we have, I'm going to move the 2x next to dx, and clearly this is u, and 2x dx is du, which means you have u to the power of 30 du, and therefore we can use the power rule. So 1 over 31, u to the power of 31, and a constant is the answer. You replace the u, you get 1 over 31, x squared plus 5 to the power of 31, plus a constant, and we're done. As always, you can differentiate the final result. You get this one without the dx. I want to look at these two questions side by side. You see in a moment why. A fractional format, in this case, more specifically, rational functions. The very first step is, can I simplify? I must if I can. The denominator can be factored. It's easy factor because 2 is a prime number, so is 3. So 2x plus 3x minus 1, make sure the middle term works. In this case, even if you don't factor, is not important because the numerator can't be factored out. So there is nothing we can do to simplify the first fraction. Therefore, u is the denominator, 2x squared plus x minus 3. If I differentiate, I get 4x plus 1. Therefore, du is 4x plus 1 dx. And remember, dx always belongs to the numerator. So I'm going to rewrite it so it becomes clear that the entire numerator is du, 4x plus 1 times dx, and the denominator, of course, is u. And that follows the natural log result. So ln of absolute value of u plus a constant, replace the u, and you get ln of absolute value of 2x squared plus x minus 3 plus a constant. And bear in mind, this expression can be positive, can be negative, therefore you must keep the absolute values. What is the difference between a and b? Well, the numerator can be factored into 4 times x minus 1, and that's the difference. Therefore, I can drop the common factor of x minus 1 and simplify it. That's the difference, everybody. So this cannot be simplified. Move on with the way it is. This one can, and we must. Since we can't simplify it any further, the choice of u is the denominator, 2x plus 3. You know the derivative is 2. Therefore, the u is 2 dx. Now, please understand, the numerator is 4 dx, but you want 2 dx. Big deal is 2 times 2. So you can say 2 times 2 dx over 2x plus 3. You rewrite it in a fashion that it becomes clear the numerator is du, the denominator is u. And that is a natural log. So 2 ln of absolute value of u plus a constant. Replace the u, 2 ln of absolute value of 2x plus 3 and a constant. What about if we have the reciprocal? If we have the reciprocal of this one, everybody, we have to do long division, in some cases synthetic division, to move on. In other words, if the degree of the numerator is equal or larger than the denominator, you can't just move on. You have to take care of the fraction. I'm going to use the reciprocal of this one because it becomes the reciprocal of this piece, 2x plus 3 over 4 dx. And the reason is because x minus 1 drops. Now, 2x over 4 is half of x. 3 over 4 is 3/4. So I don't need substitution. X gives me half of x squared. With this half is 1/4 x squared. This is 3/4 x and a constant. The point being, yes, we need substitution. Here doesn't simplify. Here it does. In this case, no need to do substitution. Again, we have a fractional format, and this is a rational function. This is not. First, you want to simplify it. You can't. Then u becomes the denominator. Its derivative is e to the power of 2, which makes du e to the power of t dt. Remember, dt always belongs to the numerator. Rewrite it so it becomes clear. You have the integral of du over u. It's a natural law. And replace the u. And the final answer is ln of absolute value of 5 plus e to the power of t plus a constant. This expression is always positive, in fact, larger than or equal to 5. You can drop the absolute value and make it into parentheses. What about this guy? The very first step is, can I simplify by factoring anything? The denominator can be factored or not. I'm going to remind you. According to the quadratic formula, ax squared plus bx plus c equal to 0, x becomes minus b plus minus a squared of b squared minus of 4ac over 2a. B squared minus 4ac has a name. It's called the discriminant. When it's positive, you have two distinct real solutions. When it's 0, you have one real solution, which is a rational. If it's negative, you have no real solutions. You have two complex solutions, a plus minus bi. Furthermore, if b squared minus 4ac is a perfect square number, then this can be factored. So is this a perfect square number? We can check it out in the following manner. This a is 1, b is 2, c is negative 1. So b squared minus 4 times a times c equals 8. Is 8 a perfect square? No, 8 cannot be factored. Therefore, the denominator is a choice option. If I differentiate this, I get 2x plus 2. Or two times x plus 1. Therefore, du is 2 times x plus 1 dx. I'm going to put the dx next to the numerator. And as I mentioned before, you can solve for dx, and that's what many texts do. But the easy way out, this number is missing. And it's a number. Put it in. Undo it with its reciprocal. 1/2. So now you're looking at du over u, and the 1/2 remains outside. But it doesn't matter outside or inside. It is a multiplier, it's a coefficient. So half of natural log and a constant. And u is replaced. And we are done. 1/2 ln of absolute value of x squared plus 2x minus 1 and a constant. And of course, this expression can be positive or negative, therefore it remains. Now, let me erase my work, and I'm going to write the reciprocal of one of them. Again, the reciprocal of this one, you have to do long division. The reciprocal of this one, the point is, you may or may not need a substitution. In this case, obviously, we don't, because this is 5 e to the power of negative t, and this is 1. So this becomes minus 5 e to the power minus t. This becomes t and a constant, and you're done. It's that simple. The point being, yes, we need a substitution. Yes, we need a substitution. No, we do not need a substitution. The integral of 5 plus 2 cosine theta d theta. First and foremost, notice the independent variable must be theta, therefore 5 gives you 5 theta. Then 2 cosine theta gives you 2 sine theta and a constant, and it's important to understand the derivative of cosine is negative, but the integral is positive, so plus 2 sine theta plus a constant. The integral of x to the power 4 e to the power of x to the power 5 minus 2 dx. As it has been mentioned, if you happen to have any exponential, the exponent is a choice of you. In this case, the exponent is x to the power 5 minus 2. Its derivative is 5x to the power 4. Therefore, du is 5x to the power 4 dx. We are going to move x to the power 4 next to dx, so it becomes clear what we have and what is missing. Now, everything is in order except this guy doesn't have a 5. You can solve for dx, but instead, because a number is missing, I'm going to put the 5 here. Undo it with its reciprocal 1/5. This is the faster way pass, okay? So you're dealing with e to the power of u du, and 1/5 remains outside. So we get 1/5 of e to the power of u plus a constant, and u now is replaced. We get 1/5 e to the power of x to the power of 5 minus 2 plus a constant. What happens when sinusoidal functions are involved? If there is one of them and the argument has an exponent, that is the choice of u, its derivative is 2x, which makes du 2x dx. Moving things around, we notice everything is in order except 2 is missing. 2 is a number. Plug in and undo it with its reciprocal. And you get 1/2 integral of sine u du, and replace the u, and integrate and then replace the u. The derivative is cosine, but the integral is negative, so it's negative 1/2 cosine u plus a constant. Replace it and you're done. What happens when both sine and cosine are involved? Well, one of them is the choice of u. Which one? The one that has the exponent. In this case, sine has an exponent. It's the choice of u without the exponent. You know its derivative is cosine, which makes du cosine x dx. So there's not much we have to do. This is u squared, and this is du. So the power rule indicates this is 1/3 u cubed plus a constant. Replace the u with sine, and you're done. Again, class, you have the entire PowerPoint available to you, so we're going over what you've seen. Most of these questions have been done in class. What if we have the integral of cosine to the power of 20x sine x dx? This time we have both of them, but cosine has the exponent, so cosine is the choice of you. If I differentiate, I get minus sine x, therefore du is minus sine x dx. So as I look at this one, I notice everything is in order except this one doesn't have a negative sign. So negative sign is missing. So I can rewrite this, and I put a negative in and out because the product of -1 and -1 is +1. It's okay. Now I have created a du here. So I'm going to write it as minus the integral of u to the power of 20 du, which is -1/21 u to the power of 21, and a constant. We are using the power rule. And of course, u is replaced by cosine. We get -1/21 cosine to the power of 21 x plus a constant. Integral of ln x quantity squared over x dx. Anytime ln x is involved, that is the choice of u. Its derivative is 1 over x, which makes du 1 over x dx or dx over x. And I'm writing both because one may see it in this format, one may see it in this format, or it may be given in that format. I'm going to rewrite this into ln x to the power of 2 times the parentheses 1 over x dx. So I'm going to separate the u and du. This is u squared, this is du. Again, writing it in this fashion is for the sake of making sure everybody can read the u and du there, which is 1/3 u cubed and a constant, and replace it. You get 1/3 ln x to the third power plus a constant. And this means ln x times ln x 3 times. So it's important to know these two are not the same, okay? This you can put the 3 in front. All right. What about this? And let me erase my work. Any fraction, the first question is, can I simplify it? Obviously, we can't. Notice, if I differentiate e to the power of x, I get this one. If I differentiate e to the power minus x, I get this one. So the numerator is the derivative of the denominator, so the denominator is a choice of u. The numerator times dx is du. So we're going to put the dx next to the numerator, and therefore this entire thing at top is du. So you have du over u, which is a natural log of u plus a constant, and u is replaced. By the way, you can drop the absolute value and change it to a parenthesis, because this expression of e to the power of x plus e to the power minus x is always positive. The integral of 0 to 1 ln of x plus 1 over x plus 1 dx. ln is involved, that is the choice of u. If I differentiate it, is 1 over x plus 1 times 1. So simply 1 over x plus 1. Therefore, du is 1 over x plus 1 dx. Now, for sure, we have to rewrite this because I want to make sure everybody can see what we are dealing with. So we are dealing with the integral of 0 to 1 ln of x plus 1 times dx over x plus 1. I'm writing it in this fashion, so I separate the u from du. So this is u, this is du. And what are the limits? I'm not going to write the limits yet, because when I'm done, and by the way, this is half of u squared when I integrate, I can go back to the original one, or I need to figure out the new limits. To figure out the new limits, I put the 0 here. I get ln 1, which is 0. I put the 1 here. I get ln 2. And that's what we get. Now, when you put ln 2, so you get 1/2 ln 2 quantity squared. ln 1 is 0, so it doesn't do anything, everybody. So 1/2 ln 2 quantity squared is the final answer, everybody. A bacteria colony increases at the rate of R of t equals 2.2 e to the power 0.4 t bacteria per hour. If the initial population is 800, find the population after 12 hours. Well, this is what is called the accumulated change theorem, okay, or the net change theorem. So if this is the rate, this is the derivative, capital R of t represents the population. Therefore, we're going to write capital R of t represents the population, and therefore capital R prime of t, or lowercase r of t, which is 2.2 e to the power 0.4 t, represents the growth rate. And what is this 800? R of 0, the initial population, R of 0. So according to the accumulated change, the amount of increase after 12 years is the integral. So the accumulated change, the increase in population after 12 hours is the integral of 0 to 12 lowercase r of t dt, which is going to be 2.2 e to the power of 0.4t. You're going to replace r of t. And remember, with the exponentials, the answer is always itself. And then you divide by k. So we're going to divide 2.2 by k, which is 0.4 here. This is 22 over 4, which is 5.5 or 5.5. You plug in 12, you plug in 0. This becomes just e to the power of 0, which is 1. But anyways, you have, and this is 4.8. You have to put it into a calculator. And because we're talking about bacteria, we're going to change it to a whole number. If it's talking about just the rate, you don't have to, but for the population, you must. The initial value, we said it's 800, add them up, and we are done. Now, there is a second method, and that is to integrate without paying any attention to the limits. So we already have the answer here. So it's 5.5 e to the power 0.4t. We don't have a constant here, but we do have a constant here. Okay, that's the function. We also have r of 0 equals 800. So 5.5 e to the power of 0 plus the, I hope you see that this is 1. So this is 5.5. So what is C? 800 minus 5.5, 794.5. Replace the C. And we want after 12 hours or of 12, meaning, and you get the same answer, meaning the advantage of this one is if they ask for the population after 10, you put 10, 20, you put 20, and so on. So you don't have to go through the integration process again and again. Okay, breathing. We can model the rate of airflow into the lungs by the function. F of t equals 1/2 sine of 2 pi over 5t liters per second, where t is the time in seconds. Find the total amount of air inhaled in one cycle, known as the tidal cycle, tidal volume if the cycle lasts 5 seconds. Remember, it takes 5 seconds, the entire thing, okay, in and out. Therefore, the time for inhalation is half of the cycle, okay? So if it takes 5 seconds, half of it, 5 half seconds, is for in, 5 half-seconds is for out. So total amount of air inhaled is the integral of 0 to 5 halves, half of this number, f of t dt. Of course, f of t is given. So we're going to write 1/2 sine of 2 pi over 5t dt, and we're going to go from 0 to 5 halves. To evaluate this, we're going to use the substitution in the following manner. We notice that it's not sine of t, but rather a function of t, so we let this one be u. Its derivative is 2 pi over 5, which makes du 2 pi over 5 dt. So to make sure we know what's going on, we are going to rewrite this in the following manner. First of all, this 1/2, in or out, it makes no difference. We're going to take care of it and put it outside. This is sine of 2 pi over 5t. And then dt, I'm going to put the dt in a parenthesis. And I'm going to compare it to this one. And I notice, again, you can solve for dt, and that's what most everybody does. But I notice 2 pi over 5 is missing, which is a number. So I can put 2 pi over 5 in here. It's reciprocal, 5 over 2 pi outside. So one more time. I kept the 1/2 outside, so it will be out of sight, so it doesn't bother us. Doesn't make any difference. It will always be there as a multiplier. Then I compare dt to this one, and I see a number, a multiplier, 2 power over 5 is missing. So if I put it in there, it's reciprocal. Bear in mind again, 2 power over 5 is just a number. And so what we are dealing here is 5 over 4 pi, the integral of sine u du, and I'm not going to write the limits yet. We have to figure them out. So first, if I put the 0 here, I hope you see that it becomes 2 power 5 times 0, and you get 0. If I put 5 halves here, I get 2 power 5 times t, which is 5 halves, and that's pi. So now I have my limits. 5 over 5 pi sine becomes minus cosine from 0 to pi. So I'm going to take the negative out. I'm going to write minus 5 over 4 pi cosine of pi minus cosine of 0. And we had done this before. This was negative 2, if you remember. I'm going to write it again. So this is minus 1, it's minus 2. Minus times minus is positive. 10 over 4 is 5 halves, so 5 over 2 pi. Everything is approximation, including the function. Therefore, about 0.796 if you go with 1.80, and the units, liters. All right, so a quick recap is to understand why we use half of this from 0 to half of that, because it's inhalation and out. That counts as 5 seconds. That's the total amount, and we want half of it for inhalation. And then when we rewrite it, rewrite it such that we see 2 power 5 is missing. All right, the integral of 0 to power 2, 1 plus cosine t dt. The moment you see t, 1 becomes t. And of course, cosine is sine t. I hope you see that we've done this before. Now we are evaluating it. Okay. So t plus sine t, plug in pi over 2, plug in 0, and we get pi over 2 plus sine pi over 2 minus 0 plus sine 0. Of course, everything is 0 here. This is pi over 2 and this is 1, and you keep it as an exact answer. What about here? You have to change the square root of x to x to the power of 1/2. So this has exponent 1, becomes 5 to the power of 5 times x to the power of 1 plus 1/2, which is 3 halves. And this one is 3x to the power of 1/2. And therefore, this is 5 over 3 halves plus 1, x to the power of 3 halves plus 1. This one is 3 over 1/2 plus 1, x to the power of 1/2 plus 1. 3 halves plus 1 is 5 halves. So this is 2. 3 halves. This is also 2. And plug in 4, plug in 1. I hope you see that this is 1, and this entire thing is just 4. Four to the power of 5 halves means the square root of 4, which is 2 to the power of 5, which is 32. This one is square root of 4, which is 2 cubed, which is 8. And so 2 times that, 64, plus 2 times that, 16, minus 4, 76. Let me remind you of one more example that we have already done, the integral of 3 to 4x squared of 25 minus x squared dx. This is x 25 minus x squared to the power of 1/2. So u is 25 minus x squared, the more complicated polynomial. Its derivative is negative 2x. So du becomes negative 2x dx. And so we are going to rewrite it again. It becomes clear that everything is in order except negative 2 is missing. Because it's a number, plug it in here, undo it here. So we have negative 1/2. The integral of square root of u du, and we're not going to write the limits yet. And this is u to the power of 1/2. And this can be integrated into 1 over 1/2 plus 1. U to the power of 1/2 plus 1. This negative 1/2 remains. Obviously, 3/2. The reciprocal is 2/3. The product of negative 1/2 and 2/3 is negative 1/3. So we can go back to the original variable and original limits and do the math, or if I put number 3 here, 3 squared is 9. 25 minus 9 becomes 16. If I put the 4 here, I get 16. 25 minus 16 is 9. Those are the new limits. And now I'm going to evaluate by taking the negative 1/3 out, okay, and then writing 9 to the power of 3/2 minus 16 to the power of 3/2. Now 9 to the power of 3/2 is the square root of 9 cubed, which is 3 cubed, which is 27. 16 to the power of 3/2 is square root of 16, which is 4 cubed, becomes 64. Their difference is negative 37. Their product is positive 37 thirds. That's the final answer, everybody.